Swayam Prabha. Digital India. Educated India.
We call this portion as the hard prototyping because what we are doing here is that we are trying to become very close to your conception of what the final idea is. Okay, so we are looking at techniques to make that happen. Let's have a look at it. We'll start with a quote. This is by Kalidasa, beautiful quote. Yesterday is but a dream. But look at what he says, tomorrow but a vision. Okay. So again repeating it, what you had as a dream which was yesterday, in tomorrow it's going to be a vision. Okay. A very nice quote by Kalidasa, fits in very well with the mandates of the design thinking and innovation course that we are doing. Because if you ideate and think of new solutions and innovative solutions, you are actually making the vision for the future, and tomorrow is going to be a better day. So, we are looking at final prototyping, okay, part 3. So, let us look at introduction to final prototyping. So, it is also called as hard prototyping because it is the final version of your idea or the concept. Here the prototype is to look as much like the way it should have looked. Okay. So, it could be the materials are correct, the shape is correct, the color is correct, the size is correct, and also it can function. Okay. At this stage, it is essential to look at a new subject, human factors and ergonomics, to make sure the concept fits in with human capabilities and limitations. Okay. That is a very important criteria because finally you are doing it for an user, so it has to fit his capabilities. Okay. So, we moved from soft to medium to hard, and this takes you very close to the final version of the idea or concept. And yeah, for us it is very important because it becomes visualized and it makes it tangible. You can get feedback, you can test it, and of course, if you think it needs to be modified, you can go ahead and do that. Okay. But finally, it leads to finalization of the idea or the design. Okay. How is it done? Okay. So, these are some of the techniques to make sure to represent and visualize the final version of the concept and be able to get feedback from the users. The first is human factors, maps user capabilities and limitations. System mapping to give an overview of the solution along with its interconnected elements or the components. High fidelity prototyping, it looks like what the final product should be. Okay, and then 3D modeling and 3D printing. Okay, it can actually produce the prototypes in 3 dimensions, many times using actual materials and along with functionalities. Let us look at each one of them. Human factors, matching user capabilities and limitations. System mapping involves visualizing the core idea with its interconnected elements. So, it gives you a broader picture. High fidelity prototyping is hard prototyping close to the final product with form and function details, and then 3D modeling and printing will give you prototypes with respect to the material size and the function of it. Let us have a look at what is human factors and ergonomics. Human factors, also known as ergonomics, is the science of understanding the human capabilities and limitations and applied to a wide variety of applications, like for example, the design of products, spaces, services and systems. It was coined by this professor from Poland in 1857. He used two Greek words, ergon and nomos, and called it as ergonomics. Okay, so that's the origin of this word ergonomics. We are giving a quote from the International Ergonomics Association, which says ergonomics of human factors as the scientific discipline concerned with understanding of the interactions among human and other elements of a system, and the profession that applies theory, principles, data and methods to design in order to optimize human well-being and overall system performances. So, that means that whatever they are building, they are making sure it actually works in tune with what the human being is able to do. Okay. So, it looks at both the capabilities as well as limitations with respect to all the sensories, okay, and also the physical, emotional, psychological, characteristics. Okay. So, it is a very vast field. We are just doing an introduction here with varied applications and branches. Here in this section is an introduction to this subject, and as part of the design thinking and innovation course. And if you are truly interested in this, we have some references, but it is a subject that you can actually do a bachelor's, master's and a doctoral program in, and you can apply it to a wide variety of applications. Okay. So, but we will look at it because you can make use of it in many ways. So, let us look at some of the broader areas of specializations of human factors or ergonomics. The first is physical human factors or ergonomics. These have to do with the physical capabilities and limitations. Okay. So, anthropometrics is the measurement of man, what is the normal man? Okay. It depends on the place you come from. So, you will have to, if you are designing for a place like India, you have to look at anthropometrics as suited to the Indian people. It is again different for males and females. So, again you will have to look at that data. Okay. It also looks at physical workload. Okay. What happens when you have different postures, okay, ambient conditions like the light, okay, and also the visual ergonomics, which has to do with your sight. Okay. So, reading, how much light should be there, how much brightness can you take, what colors are you able to make out. So, they are all part of the visual ergonomics. It is a branch of physical ergonomics. Okay. So, let us go to the cognitive human factors or ergonomics. Cognitive has to do with your mind. So, it is to do with how much of memory you can have, how much can you remember, what are your attention spans, normal attention spans, how do you perceive things, how does emotion play an important role in this, what are the typical motor responses that you have, okay, how much of information can you process at a time, and all this has got a lot of connection to human computer interaction, okay, especially the design of interfaces. Let us look at organizational human factors or ergonomics. This is to do with if you are working together as a team in an organization in a given spatial location. Okay. So, it has to do with social interactions, collaborative workplaces, how do you build social systems, okay, and how do you create environments to do many of these things. Okay. So, we have just looked at three specializations: the physical, the cognitive and the organizational. So, just looking at few of the applications here. So, let us look at physical ergonomics. Anthropometrics is the measurement of human dimensions. This is very useful while designing of workspaces, seating, controls for an operator or driver's comfort. do note the dimensions are not the same for all the users. Okay. Physical ergonomics, again part of it is visual ergonomics. This plays a very important role in the design of signage systems, readability of newspapers or publications, again control panel organization and systems where visual decision making is a key. That means that one has to look at the light conditions, movement of the eye, the path of the eye, the angle of vision, contrast in foreground and background, visibility for example at night or in low light conditions. See, all these are important factors and considerations for good design. Okay, so let us move on to cognitive ergonomics. It has to do with memory, attention, perception, motor response. All these play a very significant role in the ability of human beings to process information. So, it has a very big application when it comes to design of human computer interaction systems or applications, especially in the interfaces that you build or in the interactions that you build. Okay, so, this plays an extremely important role in it. Okay, let us have a look at organizational or human factors or ergonomics. So, it has to do with teamwork, social interactions, collaborations. Okay, so, that means if you are designing collaborative workspaces or social public space environments like hospitals or railway stations or airports, yeah, social networking systems, okay, all design spatial, spatial places for social interactions. Okay, so let us look at few instances. Okay, I am not going to details of this. Think of human factors while designing any of this. Okay, just think whether they are important. Door of a knob. Okay, I am giving different users here. Okay, it means the size of the hand and the ability to turn the knob. Okay, how difficult it is, how easy it is. Okay, does it enable you to turn it? Okay, when you turn it, what does happen? Does it open the door or does it lock the door? Okay, how do you look at a doorknob with respect to a person with a disability? Okay, let us look at wayfinding systems, what it means to a child, to an elderly person with low vision, or a person who does not know to read his particular language. Yeah. So, or you look at the packaging for medicine. Okay, is it readable for a child? Is there safety factors taken into consideration? Would the elderly be able to read it, or a person with readability issues? Okay, how do you look at contrast while actually making the medicinal packagings? Let us look at toys for children. Okay, softness, edges, color can play a very important role, the material. Let us look at cooking utensils. Okay, what happens if you are a person with low vision or if you are an elderly, can you use the same cooking vessel, or does some changes need to be made to make it much more suited for these group of people? Or look at are there mobiles for the elderly? We all know that the elderly have a lot of issues interacting with the normal mobiles. Okay, what it means in terms of touching interfaces, the size of the buttons, the size of the text. Okay, are you able to take all this into considerations while designing such devices? Or let us say look at the safety for women. Can you actually make public spaces safe by proper lighting, by having proper emergency options, or make it feel safe? Yeah, or you need to look at socially safe systems. Okay, so just putting you few instances where human factors and ergonomics can play a very important role. Okay, so case here, product design, a case study we just saw in the previous section in week 12, design of a storage unit to store vegetables. Okay, again human factors are taken into considerations, their size, the ability to carry weight. Okay, so let's move on to systems mapping here. Okay, another very useful technique to get an overview of the solution that you're doing. Okay, they are kind of similar to the concept maps which we covered in week 10 under tools, and they depict how the final solution is interconnected with the different components and how they are linked to it. Okay, and how all these parts together make this big solution. So, it gives you an overview, broader perspective of the interconnectedness of the solution in one visual representation. Okay. So, let us look at an example. This was a project that we were doing it along with 3 institutions, IIT Bombay, NTU and NUS in Singapore, and we actually had this cosmic lab where we were looking at social media for applications in healthcare, agriculture, children. Okay. So, if you look at it, you can see that the blobs on the top define the areas. We had to create a social media platform and make use of digital systems, that is the information system platform, okay, through which we actually looked at information or data units, and we came out with several applications. Okay. And we had to build an technology infrastructure to make sure that the whole thing stands on it. And of course, if you look at it, people are at the center of it, and understanding people at the middle of the pyramid was very, very important, and to make use of technology in making this was also important. Okay. So, if you look at this picture, it is a systems view of what we were trying to do at this lab, and we had put it right in the beginning, at the entrance to the lab, and you could explain what we were doing in the lab so easily to any visitors who came into the lab. Okay. So, basically what we are saying is systems mapping helps you to get a broader picture of what you are trying to do, at the same time see how the smaller components are interconnected together. Okay. So, here was a student who was trying to develop a new email interface and an innovative one. Okay. So, that is the typical one where you log in and you have a window and you get all your mails, okay, in different folders, and that is the then what he wanted to do was he wanted to make it into a slightly smarter system. So, if you look at it, when the email comes, it gets filtered and it kind of knows whether it is your friend, or not, whether it is a workspace email. So, it makes it into different clusters, okay, and it ranks them according to their priorities or importance, okay, and that goes into the inbox. So, your inbox becomes very visual. Okay. So, this is a systems level explanation of the idea that you have for a new email interface. Let us have a look at what is high fidelity prototyping. Okay. So, if you looked at it, we moved slowly from soft prototyping, low fidelity, to medium prototyping, and prototyping 3 is hard prototyping, and high fidelity is the opposite of low fidelity. So, it is very close to the concept that you have in mind in terms of the shape, color, texture, resolution and functionality. Okay. And it is great to get feedback because it is almost like the final version, right. Yeah, and you can do that. Digital versions of the high fidelity prototypes are easier to make than the 3D prototypes. Okay. So, they are great for prototyping publications, digital interfaces, packaging solutions, signage systems, card and board games. So, some examples here, for example, is the high fidelity prototype, a walkthrough of this smart device for the bedroom, which was shown as a case study in week 6. Okay. So, that is just one example of it. Okay. So, from here we will move on to doing 3D modeling and 3D printing. So, if you look at 3D modeling techniques, okay, they are great for creating objects in 3 dimensions. Okay. And it could be created physically, digitally, or 3D printed digitally. Okay. So, these are the 3 options. Okay, before the digital era, we used to make physical 3D modeling using various materials. For example, you could use wood, metal and plaster. Sometimes if the product itself is made of metal or wood, you could use it to make the final prototype. Okay, but these are physical prototypes made out of these materials. Okay, and they look very close to the final version that you want. Of course, you can create out of the 3D software a model which is very close to the final version. Okay, there are three methods of doing it. One is solid modeling, one is wireframe modeling out of polygons, and also surface modeling. So, these are the three methods through which you actually model 3D objects, and you render it and color it and you light it. So, it actually looks like the real one. Okay, and of course, there is a new technology which has come in, okay, which has become very common now, which is basically if you have a 3D model, you can actually print a 3D version of it, maybe a scale version, or you can print lots of them and fix them together to make a big size of it. But the interesting fact is when you do 3D digital printing, you can use different materials, and so it becomes almost close to the concept that you are trying to do, okay, and you can make working prototypes with that. Okay, and there are many ways or methods of 3D printing itself. Okay, so let us look at why is this important, okay, because we said this before, it is the final version of the idea, it is very close to what you had in conceptualized. Okay, so it involves hard prototyping, the next version of the ideas. We also discussed how you can make use of human factors and ergonomics to make sure what you are doing fits in or maps onto the capabilities and limitations of the user. System mapping gives you a worldview of the solution, okay, and hard prototyping makes it come alive in 3D with all its details. Yeah, so from soft to medium, now we are looking at hard prototyping. What does it involve? Just go through the steps. Okay. So, if you look at its human factors or ergonomics to systems mapping to high fidelity prototypes and then to 3D model and 3D printing. Further studies and references. We have a book on Introduction to Ergonomics and Human Factors in Engineering and Design. And Designing Interactions is a very nice book by Bill Mockridge, as well as Inventing the Future. So, we will end with a beautiful quote again by this famous graphic artist M.C. Escher. You can see him, he is reflecting his own self in a three-dimensional sphere, reflecting sphere. Okay, and his quote is a very profound quote. Only those that attempt the absurd will achieve the impossible. So, if you have something like wanting and trying out something that is impossible, you have to be absurd in the process of designing it. You have to at least attempt it. Okay, so with that we will end this section.